In this expression, we have 1 minus sine of theta over cosine of theta equals the cosine of theta over 1 plus sine of theta. I think it's pretty clear that both sides are equally complicated, so we just have to roll the dice and decide which side we're going to mess with. Suppose I decide to mess with the left-hand side. Sometimes it helps to multiply both the numerator and denominator by some factor that will assist in the simplification process. Watch what I do here. I'm going to take 1 minus sine of theta over cosine of theta, and I'm going to multiply it by 1 plus sine of theta over 1 plus sine of theta. Why am I doing this? Well, in the numerator, what I'm going to have is the difference of two squares. So in the numerator, I'll end up with 1 minus sine squared of theta. In the denominator, I'm going to get cosine of theta times 1 plus sine theta. So I have a bonus here. I should recognize 1 minus sine squared of theta as a variation of one of my Pythagorean identities, and in addition, I accomplished the fact of getting 1 plus sine of theta in the denominator, which is what I have in the expression on the right. So again, 1 minus sine squared of theta, that's going to be cosine squared of theta. In case you don't see that, we're used to sine squared of theta plus cosine squared of theta equals 1. Well, if I subtract sine squared of theta from both sides, I get cosine squared of theta equals 1 minus sine squared of theta. In other words, we not only need to be familiar with the identities as they're stated in the text, we really need to be familiar with or comfortable with manipulating these identities so that we can recognize variations of them. So in place of the 1 minus sine squared of theta, I'm going to put cosine squared of theta. Then in the denominator, I have cosine of theta times 1 plus sine of theta. One of these cosines is going to cancel out, and I'm left with cosine of theta in the numerator and 1 plus sine of theta in the denominator. That's what the expression on the right-hand side equals, so I've established the identity. Now, what if I decided to mess with the right-hand side? What do you think you'd multiply the right-hand side by in order to help me establish it or get it to equal the left-hand side? What you would multiply this guy by is 1 minus sine of theta over 1 minus sine of theta. If you did that and then did some simplification, you should end up back with what we get here. Why don't you try that just for fun?